Hello and welcome to the presentation for cryogenic power presented by Todd Smith and Nace Crawford. Cryogenic power is a disruptive technology for a greener planet. How would you like to nearly triple your current gas mileage while creating a smaller carbon footprint and substantially reducing the cost of transportation? With cryogenic power, you can. Our value proposition is that passenger vehicles, trucks, buses, and other forms of transportation can get up to 2.6 times their current mileage. If you have a Toyota Prius that gets 55 miles per gallon, it can then get 143 miles per gallon with this technology. It can be adapted to current vehicles or built into new vehicles as well. The system utilizes waste heat and liquid nitrogen to power a turbine that can create electrical and eventually mechanical energy for use in vehicles, trains, and other forms of transportation. The cost initially will be $6,200 per vehicle, but we expect to drive that cost down considerably over time. So in a nutshell, here's a diagram of how the technology works. In item number 103, you have a storage tank for liquid nitrogen. In 106, you have a typical combustion engine that provides waste heat, shown as 118. As that waste heat is fed into a heat exchanger, liquid nitrogen is also fed into that environment. Now, as a cryogen, when introduced to heat, liquid nitrogen boils and creates a gas with a tremendous pressure. And that pressure can then be fed into a turbine, number 112, that creates electrical energy, 121. And the only gas that's created is through 124 is gaseous nitrogen that's vented back into the atmosphere, a totally benign substance. So the assembly of the unit can be done with parts that are essentially off the shelf. We don't have to build anything particularly new within this system. There's a heat exchanger, as mentioned, the turbine and generator that creates the electrical power, what's called a dewar, which is essentially a tank, a gas tank for liquid nitrogen, and then the electrical components that combine the system and build it into one. So nitrogen systems are currently non-existent. There have been a few experimental vehicles, but really not much to speak of. So in looking at the industry, we really have to take a look at what else is out there in terms of alternative fuels. And the major players right now are natural gas and propane. Natural gas has a very limited penetration, 15 million cars globally and 250,000 in the US, which is a very small percentage of the overall market. It's expected to grow, but not quickly. Essentially, the major problem is distribution of fuel. It costs $1.25 to $1.75 per station to implement a new fuel. That's very expensive. Now, liquid nitrogen is already readily available in medical supply and welding supply stores, so the distribution problem will not be as difficult. It can also be microgenerated at a very reasonable cost. So essentially, we took a look at what's going on with natural gas, and it's expected to essentially triple in volume as far as vehicles on the road by the year 2020. So it's growing, and there's a definite acceptance of alternative fuel systems. So our potential customers, research has demonstrated that 40% of consumers would pay for alternative fuel vehicles, even if they are more expensive, if they could earn that money back in terms of increased fuel savings over time. Now, part of the problem is we have to educate the mindset of consumers and create that change. So initially, we'll probably be limited to fleet vehicles, larger fleet vehicles, where fuel consumption and mileage are issues where we can create a much quicker payback for our customers. And that may include government vehicles, local transportation, university transportation, and other forms of business transportation. The competition. As far as liquid nitrogen, there